Alrighty. Hey everybody, my name is Frank, this is PothOnProgramming, and today I'm doing part 15 of the Stay Down devlog, which is just this little browser game that you see here. In today's video, I'm going to be changing the p tag at the bottom of the game that records the text, or outputs the text rather, and I'm going to be replacing it with custom text that I made in a sprite sheet. So if you take a look over here, I've got text PNG. This is just going to be a really simple text set. It's got all lowercase letters, 0 through 9 for the numbers. Obviously, it's all the numbers. So just a really simple, incomplete text set. I'm just going to use all lowercase. Don't feel like drawing more of these, honestly. So let's go ahead and add this into the game. The first thing I'm going to have to do is open up the main.js file. And I'm going to have to do some prep work to get a text object that manages drawing my text into the stay down parent object, which holds everything for the game. So let's come over to where we have our get and set functions, and I'm going to make a function for get tool. Now the text object is going to be a tool, and I'm going to actually add all my tools into a container, kind of like I have a container for my constructors and for my images and for my game states. I'm also going to have one for tools, and eventually I'm going to move the controller, engine, and loader into that tools container, since these are all tools, and I want to get rid of some of these extra get and set methods that I have for setting just basically one unique object. I'm just going to make it so it can be a little bit more generic and save a little bit more space. So anyway, back to writing the get method for it. Get tool is just going to take a name. So we're going to return tools. Whatever object or property is inside of tools with the specified name is what's going to get returned. So I got get tool. I've got set tool. So let's do function set tool. And take a name and an object. Tools at name equals object. So literally the same thing as all my other functions here. Save, and then we're also going to have to return these functions as well. So get tool, set tool, save. Let's see if we broke it. Didn't break it. That's good news. Then let's go ahead and come over here and actually make a folder for tools here. New folder. Tools. It's going to have one file in it at this point in time called text.js. And that's just going to basically be an object that gives me a method that I can use to turn an input string of, a sentence or a paragraph or whatever. Take that input string and draw characters from our sprite sheet into a buffer, which is just going to be a canvas on the screen. So stay down dot set tool. It's going to be called text. It's going to be returned by this anonymous function. And I'm just going to return one single function called write. And the write function is going to, let's see what we do here. The write function is going to take a context. That's going to be the drawing context we want to draw our text onto. So that's going to be the buffer that we create in a little bit. Context, then we're going to have where on the context, so X and Y. We're going to have a stop. I guess I'll call that width for now. And then finally we're going to have the string that we want to actually write. So that's going to be the method we're going to return. I did say in this series you're going to see me write every single line of code, but that would be ridiculous for this right here, for me to actually figure out where to cut all of these characters out of the source tile set. That would just be ridiculous to figure that out and make you guys watch that, because it took me probably 20 minutes to get all of these positions. Super tedious. I'm not going to subject you to that. So let's go back to the text file here, paste that in. These frames are just going to represent the source locations of different characters in the sprite sheet. So if we take a look at A here, it's going to start at x of 0, y of 3, width and height is 6, and it's going to have a drawing offset of 0 on the x-axis and 3 down on the y-axis. So if we take a look at our image for text, and we zoom in, and we zoom out a little bit, basically it's just describing the location of the A sprite inside of this sprite sheet. So that's all those values are. So let's go ahead and save this. Also, this is going to require a function called frame to create an object that holds these values as properties. So let's go ahead and add that to constructors right now. So I'm going to add a new file for the frame constructor called frame.js, and we're going to say stay down dot set constructor, nope, not set controller, set constructor frame, and it's just going to be a function that takes x, y, width, height, and offset x and offset y. And offset x and offset y are actually going to be defaulting to 0. This way I don't have to specify these every single time. So let's go down like that. Now we're just going to return an object literal with all those parameters. So x, y, width, height, offset x, offset y. Great. So this is a little bit different than what you've seen me do with classes or object constructors in the past. Normally what I do is I'll go the class inheritance way, which is basically going to define a prototype on the constructor. So I've got my constructor here. For this one it's item. It's going to make a function. When I want to make a new item, I'm going to say new item, and I'm going to pass in x, y, width, and height. Item is going to have a prototype. Right now the prototype for item is copying the prototype of rectangle 2D. This is great. I just simply don't need this for this constructor right here. I would much rather just be able to say frame, pass in my parameters, and be done with it and get the object that I'm expecting. So that being said, the benefit that you can actually see is instead of having to do this, now I just have to do this, which, you know, you might like it, you might not like it, but at the end of the day, they both do the same thing. And you could even argue, based on some things that I read on the internet, that object literals are a little bit faster than using the new operator. So, but you should do your own research on that and use it according to your own application, and your, you know, best fit to your needs is what you should do. Don't just start doing this because I'm doing it. I'm just happening to be doing it right here for this particular use case, because I don't want to write new all these times. So now the next thing we need to do is actually get that frame class into the application. So let's go to the HTML file. Let's go to where we're importing constructors, and let's go down here. Script source equals constructors frame, and see if anything's broken. Nothing is broken yet. Cool. So now what I want to do is I want to get my new text tool inside of the run game state so I can start using it. So let's go ahead and say const text equals get tool text. Save. Let's see if it works. It works. Let's see if we can, or text dot write. Let's see if we can get that method that we put inside of text just to make sure it's real. Cannot read property write of undefined. Well, why is write undefined? Did I forget to pull it in? Probably. I think I forgot to pull it in. So let's go ahead and right here do script source equals tools slash text.js, close that, save. Here's something to note, which I haven't found a way around quite yet, but because the text tool uses the frame constructor, you have to place this underneath where you're loading the frame constructor. The frame constructor has to load first, the text object has to load second. This way it has access to the frame. If I were to switch these, frame would be undefined when I try to call it like this. I would just get undefined. Let's see if that fixed it. Frame is not defined. Text.js line 5. Why is frame not defined? Let's take a look. Did I do this right? Tools/text constructors/frame. Frame is still undefined in text because I'm not importing it. So if I were to actually do this the right way, what I would do is say const frame equals stay down dot get constructor frame. I'm not sure if I wrote it with an uppercase F or a lowercase f. Let's take a look. Uppercase, cool. Don't think I'm going to need this anymore, so I'm going to close it. Let's see if we fixed it. Okay, so now we're outputting the write method, and there's nothing in it, so we're getting what we want. Everything seems to be working just fine. All right, cool. So now let's come back over here, and we are going to have to add another buffer. I don't like the way this is set up currently. I don't like that I'm defining these right here. I want to define these probably when I initialize everything, because that's where I'm defining everything else. Well, I guess everything else is being defined when I load those files in. I don't know, this doesn't look right to me, so I might change this in a little bit, but for now we're just going to do it inline. So I'm going to say text is a property. It's going to be a canvas context. So I'm just going to copy, actually I'm going to copy this one. Create element canvas, get context 2D, alpha is false, desynchronize is true. Get rid of that trailing comma, save, refresh, everything's good. Oh, that's what I need to get rid of. I need to get rid of that alert. Save and refresh, cool. Then we need to set up that buffer, so the text buffer. To do that, I'm just going to come down here into the initialize method. I'm going to copy the setup for this buffer right here, the display buffer, and I'm going to just make this point to the text buffer, because we're going to change the size of this to fit right down here in this little bottom area. So I'm going to say this is still going to be 256 pixels wide, but it's only going to be 32 pixels tall, because that's the height of two of these. So let's go ahead and do that. Alright, that's good. And then what we also need to do is shorten this background buffer, because there's no reason for it to be this tall when we know we're going to be drawing other stuff over top of these last two rows. Why draw them if we don't have to? So let's go down to where we are actually doing that. Alright, instead of 256, I think we need to do 224, because we're going to subtract 32 pixels from the height. So let's save it. Cool. Alright, that is what we want. And then also down here, I'm going to have to undo this as well. So let's put this back for a minute so we can see what I'm actually drawing. Y equals 212. This should get us right to here, and only draw from here up. Cool. Alright, so now we're only drawing tiles down to here. We're taking off those last two rows in our for loop. Now I know it's safe to come up here and reduce the canvas height to 224. Cool. Alright, so now we are open and clear. We can draw our text to the buffer that sits right here. We still have one thing in the way though, and that is the original p tag that we're currently writing to. So let's go ahead and go into the run game state and just get rid of that. So the first thing I need to do is, instead of defining output as a constant, I'm going to define it as a variable, because it's going to be changing, because it is just going to literally be the current text that we're going to display. So actually, I might not even need this to track the text that I want to display. So we might be able to do this a little bit differently without output at all. So let's go ahead and just get rid of output completely. That is going to require us to find every instance of output. We no longer need to append it. We no longer need to set it to something when we activate. When we deactivate, we don't need to remove that P element. And let's see if I can find any other instances of it here. We don't need to position it when we resize because it's no longer going to be an element in the DOM. See if we can find any more. Okay, this for now, what I'm going to do is I'm just going to empty these here. Save, find, let's see if we have any more output. And finally over here. Alright, cool, no more output, so we're output free. That means we can go ahead and start writing our method to draw some text to the buffer, which we're then going to draw to the screen. So let's come in and see if we can write something. So we obviously want to get an image, and we're going to have to get, well, I guess I can't do this until I load the image in. So let's actually do that first. Let's do media/images/text.png. Cool. So now we're loading up the text, and we're going to go ahead and add that image. Images.text equals images_5. Because it's the 5th image we're loading in. Let's see if we broke anything. No, we're good. Okay. Let's come over here, and we're going to say get image. Stay down dot get image. We're just going to have a reference to that method so we can get an image when we need to. So the image we're going to be getting when we write is going to be the text image. Get image text. So var image equals get image text. And if I had like different fonts or something, I could put in something up here to specify which text image that I want to pull in, and I might even specify which frame set I want to pull in to match the image, because obviously this frame set is unique to this text image. So I might put some parameters on there to specify which text set and which frame set I want to load in here, but for now I'm just hard coding it in so I can make more work for myself in the future. But let's go ahead and just hard code it and get the text image, then context.draw image. For now I'm just going to draw the image and see what we get, just to see if things are working. And it's not going to do anything yet because I haven't actually started to draw that buffer down here yet. So let's go into the run game state. Close that. Let's go into the run game state, into the render function, wherever that's at. Render. Let's go right here and do buffer equals get buffer text. So up here we defined a variable called buffer, and the first buffer we draw is the background. So I'm just saying buffer equals get buffer background, and then we're going to draw that buffer to the screen. So this draws our background. Then we go through our platforms, we draw the diamond, we draw Dominique, we draw the spikes, which I also want to add a buffer for, instead of doing this every frame. And finally we're going to get another buffer called the text buffer, and we're going to draw it to the screen. Same way we drew the other buffers to the screen. Or I guess we're just drawing one at the moment. Let's see if we can get it to work. Save, refresh. Well, there's nothing in it yet, so that might be a problem. Let's see if we can draw a red square in there. Let's do buffer.fill style equals red fill rect 0 0 2020, save, refresh. Okay, so we're drawing it. It's just at the very top of the screen. So we need to specify that we want to draw this down at the bottom. So when we draw our buffer, we're going to get it from there and we're going to draw it. Can I just say 224 for the destination for the Y position? Save. Sweet. Alright, so now my text box is down here. It's covered up on top by this little ground thing that I got going on. This line I'm drawing for the ground. By the way, I think I'm going to fix that real quick because there's no reason for me to have ground.top when all I'm recording is just a Y value. So instead of doing ground equals an object, I'm going to do ground top, and I'm going to set that equal to world height minus 32 instead of having an object because that just is bugging me. Let's go in there. Yep. Paste, save. We're going to search anywhere we have ground.top. We're going to replace it with ground_top. Ground.top. Replace. Replace, 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 replace. And hopefully I don't have any errors as a result of that. We should still get this extra gray bar right in the same spot. And we do. Okay, cool. And we cleaned up an unneeded object, so that's good. Alright, so next thing we need to do is actually write some functionality to draw this text. So what I need to do first is figure out what the first character in the string is so I can get the frame, the source location of it in the tile set so I can draw it. So I'm just going to come in, I'm going to say var char equals string dot oh, actually, wait a minute. Why isn't it drawing the image? Because I'm telling it to draw an image right here. Context.drawImage image. Is this image not? Is this image not loading or something? Let's see what it says. Oh, I haven't actually called write yet. That's dumb. Okay. That would have been terrible too. I would have froze it with an alert if I actually was calling it inside the game loop. That's a terrible idea. Shouldn't have done that. Luckily, I haven't been calling it yet. So the first time I want to call it is when I activate. And I want to give it a message that says something like, hey, I want to get out of here, like where am I at? So let's find the activate method and let's say text.write display. We're gonna inset it like 4 pixels. We're gonna downset it like 8 pixels, and we're going to have a width of, well, I guess the width should be like 248, right? And then that's the width of our writable text area, by the way. And then finally I'm gonna pass in a string that says, where am I? I need to get here. Hey, what's that diamond thing? And hopefully all of that fits. Let's see what we get. Should draw the whole image, but instead it gave us horrible error. Cannot execute draw image on drawing context. 3 arguments required, but only 1 present. Okay, well, that's my bad. So if I come back in here, I should just come in and say image 0 0, or actually x y. Refresh. Still get nothing. Let's get rid of the red square. Come back into the render function. Come down here. Save, refresh. Still have a problem though because it's not drawing my image. So let's do console.log image.width and see how wide the image is that we're pulling in. 218 pixels. That seems about right. So I know I'm getting the image. So what's the problem? Is it the context? Let's see what we get when we log the context. That should be 256, but it is undefined. So let's see what the problem there is. I'm obviously not getting the right drawing context. So I'm saying get buffer text. So that means maybe I made a mistake when I was defining text. So let's go back down to where I'm setting everything up. Buffers.text.canvas width and height, buffers.text.image smoothing enabled is false. If I come up here, I have text. Looks to be defined properly. Then I'm coming in, I'm also loading the text image, obviously because that had a width of 218, which seems accurate to me. Logging context.width, maybe it's the way we're passing context in. Buffer equals get buffer text. So let's come in here and cut this out. Save it, come back over here. Come back to the render method and see what the problem is with our buffer. First of all, buffer.width shouldn't even return anything. Yeah, okay, so it is a canvas. It is what I expect it to be. Buffer.canvas.width, that should be 256. It is. Okay, so what's the problem? I don't understand. I should draw the entire image at, oh, that's my mistake. Is that my mistake? If I come up to activate and see where I drew it to, I thought I drew it to like x of 4 and y of 8, but why would I even put 8? Why wouldn't I just put, I guess 8 is where it should be. Text.right, not to the display. That's my mistake. Text.right to the get buffer. Right to the text buffer, save, refresh. There it is. Okay, so we just drew our entire character set, just the image. We're not actually grabbing individual characters based on that frame set, but that's coming up next. So we need to loop through each character in the string. So for var I equals, we're going to do it in order. So we're going to start left to right. And the reason we need to do that is because we're going to get to a certain point where we might overflow the bounds, the x bounds. We're going to have to keep track of that as we place each letter from left to right, and we're going to have to jump down to the next row to start writing there. So we're going to start at 0. I is less than length. I plus plus. Length is going to be string.length. Okay, and then we need to get the char, or the character, at the index in the string. So we're going to do char equals string dot get char I. I'm not sure if that's right. It's either get char or get char at. So let's console.log whatever we get for char. String.getChar is not a function. Oh, you know what? I bet it's just char at. Yeah, let's see. And the very last character in the set is a question mark, so that's accurate. Cool. So you can kind of see where this is going. I was able to pull the last character out of the string that I passed in, and that last character is just a question mark. So that comes over here, and it tells me where this question mark is inside of this image. It's all the way at the end. So this set of coordinates here just allows me to cut that question mark out. Alright, so no longer need to load char, but let's just do a simple check just to make sure we're not putting anything in that we're not able to draw. I'm just going to say var frame equals, what is this called, frames? Frame equals frames char if frame is undefined or something else that evaluates to false, then continue, just skip it. So if we have a random character in there that's not in our text set at all, we're just going to skip it and continue like it's not even there, which is kind of lame, but I have no reason to add anything else. I'm going to be writing all the strings that go into the game, so there's no reason to really go beyond that for my purposes. Alright, so now we have the frame coordinates, so we need to draw image, the image, from frame.x, frame.y, frame.width, frame.height, and we're going to draw it to, and by the way, we're going to have to do, I'm going to call this position x, position y. We're going to draw from the image, from those source coordinates to the destination, position x plus frame.offset x, position y plus frame.offset y, and then frame width and height again. Alright, let's see what we get. Alright, everything is in the same spot because it drew it all at the same position. So while I'm looping, I'm going to have to do this. Position x plus equals frame.width. Save. Cool. So you can kind of make it out. It says, where am I? I need to get out of here. Hey, what's that diamond? And then it cuts off. So we haven't implemented bringing the text down to the next line yet, but we're looping through our string, we're grabbing each character, we're checking for the source of that character in the sprite sheet, and we're drawing it. So let's go ahead and make a constant over here called letter spacing equals 1. Letter spacing equals 1. So when we add to our position x, we want to add the width of the actual frame plus letter spacing. Save. See what we get. Alright, I can make out each character much more clearly now. There's just one pixel between each of them, but I still don't have any spaces. And in fact, in my character set, there is no, first of all, I'm not going to include an empty space in my character set because that would just be ridiculous because I'm not going to actually draw anything. So why would I draw empty space? So that's out of the question, but what I am going to do is detect when the character I'm encountering in the string is a space, and I'm going to add to position. So let's take a look at what the character is before we even get the frame based on it. And I'm just going to say if char is space position x plus equals space width, I'm going to set to 4. I think that's a pretty decent space. So I made a constant for it, plus equals space width. Oh, and also continue, because we don't want to try to draw something that obviously isn't in our char set. So let's see what that does for us. Okay, so now we have some spaces. Let me try 3. Let me try 3 because that might be a little too spacey. I think I like that a little bit better, a little more condensed. 3 pixels between letters. Actually, that should be 4 pixels between letters because the spacing already adds letter spacing, which is 1 pixel. So cool. So this is a spacing of 4 pixels between characters. Alright, so the next thing we need to do is drop characters that overflow onto the next line. So let's take a look at how to do that. We're just basically going to say if position X is greater than width, position X is 0, and position Y plus equals line height. So now I need to define a constant for line height. So let's come up here and say const line height equals 10. I think 10 should do because I'm pretty sure my letters are at max 9 pixels high. So let's save that and see what we get. Hey, that actually works. Now it's not going to work super clean like your browser implementation is. Like, not your browser implementation, but basically with a p tag or any text element in HTML, there's a whole lot of work that goes into formatting the text that gets outputted in those elements. So we're doing everything from scratch here. All those bells and whistles are gone. But what you do get is your own custom text that you are drawing to the screen, and you have absolute power over what you want to do with it. You just have to make it happen with the JavaScript. So I'm literally just going to cut off any characters that overflow and move them down to the next line. One thing I do want to do is maintain the margin on the left hand side. So let's do margin. How am I going to do margin? Because right now I'm saying position X. I'm starting position X with an indent, but I really shouldn't be doing that. I should have a margin. So let's have a margin up here and just call it margin equals 4 pixels. Save, come back out to the run game state, and in the run game state we're going to say start at 0 and start at 8 down, which I'm going to change to 6 down. Save, refresh. Now it's going to start right up against the left side, which I actually don't think is too bad. I kind of like that. In fact, I have a lot of space here, or I have very little space, so I need to maximize my space for my text. I still should have a slight margin though, so let's come in. Instead of 4, let's just do 2. Might even be able to get away with 1. But let's come in here and position X equals margin position X plus equals margin. Cool. So now I have my margin. There's an indent. Let's take a look at what I specified the width to be. Now let me just think about this for a second, because I'm drawing my first character for sure. I'm going to know how wide it is, and I'm going to add 1 pixel onto it based on my letter spacing. So let's say I try to draw this W, or I just finished drawing this T. I know my X position is right here. Why is this? Oh, because the width isn't a full width. The width, we have a good case to test with here because this apostrophe is very small. So let's see if we can bring the width down just a little bit to test how the line break works. I said 248. Let's do 246. See if that does anything. Alright, let's bring it down to 240. Alright, so that brings the T down. Let's do 241. Nope. 241, still the T is down there. 242, still the T is down there. 243, still got a T down there. 244, still down there. 245, I picked the wrong, there we go. 245. Alright, so 245 is literally it's like right here, because we're one point past. Actually, 245 should be like right here, and we draw that extra character there. I'm not sure if I like that, but because you're not really cutting off before the specified width. So if 245 is like right here, we're drawing our T one letter past that. So what would really be good is if we kind of projected what the width of the next character is going to be, and then determined if that character was too far, and then brought that character down to the bottom, because I could have a really skinny exclamation point that can totally fit on that line. But if I were to put a W, or like a capital W that's extra wide in there, it would overflow the screen. So it's not the best way to do it, but if I make sure that I don't have too much or too little space here on my width, I should be fine. Anyway, this is fine for my purposes. Let's keep going and fill out the rest of this text so we can see what happens here. Nothing happens yet because we're just writing it here. So let's take this method. Actually, let's do 246. I should actually be able to get this to have that apostrophe up on the next line too. Oop. Dang, this is really... There we go. Yeah, I'm not liking that. I'm just going to do 248. Okay, cool. So now let's just take this line and just move it to where we need to write more text. So I'm going to copy this. I'm going to come down to collide player with platform. Nope, that's not it. Resize, don't need to do anything there. Render, don't need to do anything there. Update. Okay, if this is where it is, I believe. Here we go. We're going to say something there, and we're going to say something here as well. So if item count is 0, and we hit the top of the screen, meaning we hit those spikes, I'm going to say something like ouch, I need to stay away from those. And if I have more than, well, if I have any amount of diamonds, let me drag this down here. If I have any amount of diamonds, I'm going to say, oh snap. Lost my diamonds. Let's see if that works. Alright, so it starts out, where am I? I need to get out of here. Hey, what's that diamond thing? If I collect the diamond, and then hit some spikes at the top. Oh, I'm forgetting to refresh. Alright. So let's do... I need to clear. Buffer equals get buffer text. Canvas.width equals 256. Okay, that will effectively clear the buffer. And then let's see if that works. Except now I can just say buffer. Alright. collected a diamond, didn't clear it. And the reason it didn't clear it is because it's already drawn. It did clear the buffer, but it did not clear the display, which had already had that text drawn to it from the buffer. So I'm actually going to have to fill this buffer every time I want to draw in it. So it can't be transparent. It actually has to have a black background. So let's do buffer.fill style equals all zeros, buffer.fill rect 0, 0, 256, 32, that's the width and height, save. This should work, but I'm probably going to have to call that fill more often. Okay, so now it says, oh snap, I lost my diamonds, or if we just hit it, it should say, ouch, I need to stay away from those. Alright, cool. Well, that'll say the same thing. Now we just need to make it say something when we actually collect the diamonds, which is basically just going to be the count. So let's come back in here. Make sure we do this for activate as well. Text.write to the buffer. Get this whole thing. I should probably just put this in a function. Or honestly, what I should do is I should just put that into the I'm not going to need to do that because I'm going to have some kind of background drawn here that's not just going to be empty. I'm going to have kind of like a text box background to make it look nice and not just like this black area. So this will eventually go away, which is good because this is really sloppy. I don't want to do this every time. I'd much rather build this into the actual text method here and just clear the background to black right here, or you know, clear the background somewhere else but with just a simpler function call. So for now this is fine, but there will be refactoring needed. So let's go down to where we're keeping track of item counts. So let's take a look at item counts. If item count equals 0, item count equals 0, item count plus plus, here's our other output. And we're just going to write the item count. I'm not sure if this will work with just actual numbers. They might have to be strings, so let's take a look. Yeah, so right now I'm not getting any output, and I think that's because item count is an actual number and my text method is expecting it to be a string. So let's go back to run and just make it a string. So I'll just do item count dot to string, use the built-in object method, and see if it works. All right, cool. So we got 1, 2, and it should go all the way up to, you know, obviously it'll go up to the double digits and triple digits. That should work just fine. I have tested this, but not to triple digits, obviously, because that would take a while. But anyway, that looks like it's done it. Let me take a look at that 5 again. And no, the 5 is good. It's just, if you take a closer look at this, what you'll notice is that because the text is being scaled by the canvas, I guess, as it's being scaled up with CSS, you're gonna get some variations that might not look too good. So like if I come over here and dock this on the right side, you'll see as I downscale, you can see sometimes the text kind of fluctuates in size. Like you'll see here, this is obviously a much thinner column than over here, and that's just the way it's being scaled. So this is kind of one of the downsides to this approach, because if you use a p tag, you're going to get some pretty crisp text every time. When you use this approach, depending on how the screen is scaled, that text is just going to be a little bit distorted, especially when you downscale. Like when I downscale, can't even read that. It just becomes a blocky mess. But if anyone tries to play the game at that scale, they're destroying their own user experience at that point intentionally. So as long as you play it at a higher scale, it should be fine. And anyway, that does it for this installment of the Stay Down devlog. So I hope you guys learned something. I know it takes a long time to do these videos, but I'm just trying to capture every line of code written as I write it. And next series, I'm probably not going to take this approach, so you don't have to worry about that. But I'm going to see this series through to the end. So anyway, that does it for me. See you guys in the next video.